I'm Marie Tréguier. I'm a CNRS scientist working in Brest at IUEM. I'm an oceanographer specialized in ocean eddies, and in EERIE I am co-coordinating Work Package 6. Within EERIE there are two kinds of teams. In fact, there are the teams that actually do the ETH experiments at the large computing centers, and there are other teams like my team who are in EERIE doing analysis of the results and trying to expose different processes that happen in those ETH climate models. Well, my interest in EERIE is mainly in the ocean, and in that respect I think that what EERIE has achieved is to demonstrate that coupled models with an eddy-rich ocean are really very realistic and can help us learn about the processes that are going on between the ocean and the atmosphere in a much more realistic ocean, because in reality the ocean has eddies everywhere you look. With sea surface temperature, sea surface height, you see eddies everywhere, but the usual climate models don't have those ocean eddies. And before EERIE and before perhaps earlier projects, the climate models were just not realistic enough to give us confidence in the processes that were going on. But now with EERIE we have those four eddy-rich models in which many processes are represented with very good accuracy and degrees of realism. So now we are more confident to really look at what is going on, like when eddies have the atmosphere above and exchange heat and receive freshwater fluxes from the atmosphere. All that is really interesting when you reach a certain degree of realism. And what is important in EERIE is that you have four models, not just one, which means that when results are robust across models, then you can have also more confidence in the results. I think that we are now beginning to see that with those eddy-rich models we can look more in depth at what is happening on the continental shelves. And these are very important areas in terms of fishing, ecosystems. They are close to the coast, and before we would not even consider a global coupled model to be able to represent what was going on there. So with EERIE we looked there, perhaps carefully at the global scale for the first time, and Audrey Delpech found systematic bias due to the fact that in EERIE model we haven't put the barotropic tide, the main tide, which has a very strong impact on the shelves. So now we are getting to the point where we really see that the potential of those models to represent the shelves, and we can even point out that okay, we know that this process, in the next step we will need to take it into account and to introduce it if we want to have the sea surface temperature and the air temperature right over the Celtic shelf, for example. So this is really a step forward in terms of what we can use those eddy-rich models for. There is first an international framework, which is IRES-MIP. So this is this international collaboration of high-resolution experiment, and thanks to EERIE, Europe is really very well and centrally positioned into that IRES-MIP effort. So obviously, IRES-MIP is, in one sense, the future of this intercomparison project like CMIP, but perhaps also one branch that will inform the other branches. For example, we are not sure that in the future we will be able to have eddies for all climate scenarios that also include all the Earth system processes like fires, like biogeochemistry in the ocean, and ice sheet and whatever. So at some point it becomes too costly, but maybe what high-resolution model will do will be to inform these other models so that the missing processes can be taken better into account in these Earth system models of the future years. And also one thing that is very important is that ERIE actually developed those models and evaluated them carefully for long climate simulations. And that is really central because the same model are also being used for things like seasonal forecast and shorter term experiments. But really, especially for the ocean, you need to run them for decades to really understand what the behavior is and have a robust assessment of what the model are doing, what is their quality. ERIE has secured a vast amount of resources in terms of computer time, in terms of data storage, and a lot of new developments have been made to make data easily accessible, for example, the ERIE cloud. So the facility with which we can access the data make us want to do plenty of things, and at the end the bottleneck is the human resources to do all this analysis. And I think even more than in other projects before, because in other projects before you could say, okay, it's so difficult to access to the data, my program is going to run for 1 week before I can even look at something in the model. This is no longer true. I mean, in 5 minutes you can look at something in the model. So really what the bottleneck is now is human resources to have a critical look at the data, ask the right questions to get answers that will serve the community and will advance science. The first thing is simulations and the data sets. Those are going to live for a long time. I mean, when we look at a previous European program that was Primavera, that was a contribution to IRESMIP, those simulations are still being used today. So 10 years from now, I mean, I expect that ERIE simulation may still be used for scientific analysis.